Are you ready?
Are you ready? You all? It's the last final 1 hour, so yeah. And also very thank you for all your interest and questions during the previous lecture. We really appreciate about your participants and questions. So yeah, let's move to the last part. Actually, this one will be very helpful for particularly for Unit 2 group because they're gonna do on-site survey this weekend. Because we decided to bring this program to this workshop because of course it's really good to just do kind of computing and analyze the network system with your computers, but on top of that, if you visit actual site and then kind of you can feel the results of your analysis. So we just try to give you kind of two different experiences, understand urban network. So yeah, I will start. Yeah, today we are going to do the on-site survey and COVID-19 urbanism issues. It's gonna be short. It's kind of very straightforward and clear concept. So to count pedestrian volume studies, there are three different ways. The first one is a manual counting, and second one is automating counting and video counting. So what we have to do this because the counting data is a kind of reflect the actual people's movement and pattern in the city. For example, if you see this graph, there is a kind of, you can see the pattern like here. This is the manually counting the pedestrian movement in 4 different neighborhoods. So it has a slightly different pattern you can see. Like here, we can see the morning peak hour is around the 7 a.m. to 9 a.m. And this is like afternoon peak hour from like, for example, this like from noon to 3 p.m. and this is like evening peak hour from like 6 to 8 or 9 p.m. So this is a kind of reflect our movement pattern in cities as well. So normally the researchers and transportation planners, they do kind of this daily volume distribution counting exercises for each cities to understand how the residents who are like people actually use the city pattern. And also, if you see this diagram, actually depends on the land use type. It shows a different pedestrian flow pattern as well. Like if you are in the office, there will be this kind of 3 parts. And if you are in like recreational places such as like park or open public space, it will show like this kind of just one hump kind of graph. But if you are in a like residential area, it's usually showing the 2 peaks graph. But it's kind of understandable, right? Because it's a morning peak hour. People go to job or go to school, or an evening peak hour, people come back to their home. So depends on the land use type, the pattern of graph will show differently. I will show you how to do like I will show you some videos to explain the way of counting. The first one is about the manual counting. So as you can see, it's literally just bring the paper, table paper, and then just count at the corner of a street. So the unit 2 will do this kind of similar exercise on our research site. It will be the one of the Hangang River Park. I prepared the file today, so I will just to show you how to do it later with NNA toolbox as well. And second way is the automatic counting way by using sensor. So there, yeah, there is a kind of like sensor machine. People just install it and like this. And then if bicyclers or like pedestrians just pass by this sensor machine, this one just count automatically. This is also very popular way to do, particularly for like governments or city planners, they try to do. And recently, this kind of video counting is also popular for researchers. So just recording a street and then they just using the video counting and just simply yeah, automatically counting the number of people on a street. So there are 3 different ways. So yeah, we're gonna use the first one, and you just to go to the street and then just see how people walk and how many people flows on the area, and then you will compare with your NNA analysis results. So it'll be very fun. Like you can have 2 different experiences to understand urban network pattern. So I will show you a example of counting exercise using counting exercise. So this is a project which I done at Harvard GSD, and uh, we this is the site from Cambridge in Massachusetts, and we using accessibility analysis. Um, So what we want to do is that we want to collect the peak hour pedestrian activity around the central station area, and with on-site survey, and we also do the like computing accessibility analysis, and then we just compare with both files and then find the linear regression results and then how those 2 files are close to each other. So we here is the research site is Cambridge, and our hypothesis is what factors affect evening peak hour pedestrian flows, and this we build the prediction model, and we also do the on-site survey, and we do the prediction model of adjustment by using on-site survey and computed prediction model. And lastly, we propose a design proposal for new urban use and building use plan. So here we decided 9 different hypotheses for the size. So first one is distance. So how the shortest route from somewhere to the metro station, and about density, land use type, and road hierarchy, and road type, road safety, living frontage, and sidewalk condition, and green space or amenity. So we defined the 9 hypotheses for the site. And then among them, we thought that this particularly 3 things, distance, density, and land use, are the key kind of element to influence pedestrian volume on the site. So we focused on these 3 key things. And then based on the hypothesis, we think about the possible pedestrian routes during evening peak hour. So we thought that it could be 4 scenarios. The first one is travel route directly from station to home. After work, people will take a subway and then just walk to home from station. And the second route could be on the way to home. They can go to restaurant for dining, or they can go to grocery shopping. So they can make kind of detour on the way home. And the third route could be for officers, employees. They can back home, but they can walk directly to the station, but they can also make some kind of detour for other kind of activities. But when we did the survey, it was a very cold and snowy day. So we expect that first route and the fourth type could be more dominant with the pedestrian flows. And here you can see that first we understand how many buildings can be accessible to this central station. So it will be the 3,400 buildings around. And then, yeah, in the first lecture, I explained about the distance decay, right? This is the discount number about the pedestrian volume. So here you can see that the origin is T station and destination is all buildings. So here explain that this is the decay value. So if it is a red, it means that almost 92% people can survive around this area. But once it became like dark blue zone, it will be only like 1 or 2% pedestrians can be survived from station to these building areas. So in this research, we used the beta value 0.004 because it was very cold winter and also the evening peak hours. So we thought we considering this kind of condition, we decided to take the highest beta value while we're calculating the accessibility analysis. So here is the result. This is the result of the between the centrality analysis I explained in the first lecture, right? So between the centrality analysis reflects the actual pedestrian flows on the street. So here you can see that the color range explains the density or number of actual pedestrian flows. So here is a red. So it will around like 250 people will pass by this street. And light green is like around 100 people pass by this street, but it's like this dark navy color showing the almost like 0 people can walk, can pass on this street. The reason why is that we use the very, very high distance decay because of the weather and the time. So that's why this pedestrian survive discount shows very dramatically drop down, even if just like here would be like 300 meter or 200 meter distance, but above that, like almost no people can survive in this area. So based on this between this analysis, we decide which location we want to go and examine. So we selected, it's better showing the next slide. So we selected top 5% busiest street and then low flow percentage street we selected. And then we define the kind of in between percentage pedestrian volume street here. So as you can see here, E, F, G, H, I, J, K, L is a very high volume of pedestrian flows, which of course will be located around here, which is like the color range represent the top busiest street. So we decided to count the pedestrian volume like here. And then also by the number, by the percentage, we also selected some important node and street, and then we go and begin to count. And at the same time, we also take some photos on the street to show the street condition as well. So for the on-site survey, also not only just count numbers, also take some site photos will be very helpful to understand the context. So you once complete this file, yeah, this one I can skip it. Once you complete the discounting data, we can compare with this computing accessibility analysis data. And then what we're gonna do is do the row correlation and Pearson rank correlation analysis. We will try both. And also we draw the linear regression line, fit line here, and then see how those two data, how much they correlated each other. We're gonna see. In this project, we designed the 3 different scenarios. The first scenario is about origin is the buildings, and destination is station, and the weight is housing. So actually, the building represents the housing. So we just select the housing and then use as a destination location. And beta value is of course 0.004, and walking radius is 1 kilometer. And then the results showing that the correlation is over 72, and Pearson rank is 78%, so pretty good. So which means that the results of this computing accessibility analysis and then on-site survey data is a kind of match very well. And second scenario is the first scenario is using destination with housing buildings. But the second scenarios, we use the destination as a job, which is office building. And other, the condition is all same. And as a result, the row correlation shows like 90%, and Pearson rank is 86% match with the on-site survey data and the computing accessibility analysis data. So which is pretty good, very good. It's really matched well. So it shows really good results. And then third scenario is now we combine with the housing and job location and then use it as a destination. And other condition is same, and correlation shows that 89% match with the on-site survey data and computing analysis data. So what we can say is that actually the highest performance of the correlation analysis is this case. So scenario 2 is the most kind of fit well with the survey data. So from this analysis, what we found is that number of jobs contributes more the pedestrian workflows around the central station during evening peak hour. Of course, if we count the morning peak hour or afternoon peak hour, it will be a very different findings or different results might have. But this is the evening peak hour. So in this specific time and location, the job contributed the most for the pedestrian flows. So if we really, so if city government really want to increase the pedestrian flows around the central station area, so what we can recommend is that add more FAR or GFA of jobs around the station areas. And it is just really greatly influence on the pedestrian flows. So based on the analysis, we can propose land use plan planning. So actually here is the central station location. So we selected this one block, urban block, as our study site. So here are 4 buildings actually. So these 4 buildings generate how many pedestrian flows generate with the 4 buildings we calculated. So this results showing that in these 4 buildings there are 250 employees in this building actually, and then between this analysis showing that over 850 pedestrian flows are generated on this street. So if we wanna make kind of double pedestrian flows on this street, what we can do, we have to increase 11 times more of employees on this block, and then we can generate almost double uh, volume of pedestrian flows on this street. So here are the ways to calculate it. So yeah, next week, if during our prep session, I can explain more details about that, how to calculate and how to examine back and forth with the current condition and with your new proposal. So if we want to increase almost 11 times more employment on the building, what we have to do is that we have to increase more GFA of office buildings, right? If we increase more office, there will be more employment. That is our hypothesis. So here is the number, what we have to increase of the office space on the 4 blocks, and also transform this number to number of floors. So we need almost 40 floors more on this building plot. So there is 2 different scenarios. Like here, it's like more concentrated kind of like strategy. Here is a central station location. So if we wanna improve like almost double flows of pedestrians on here, we have to increase this number of volume on this block. But if we just first strategy for this urban planning, of course, we have to distribute this volume to other neighborhood buildings. But in terms of, because of the distance decay, actually, it has to build more, almost 3 times more GFA, and almost like 3 times more employees on this neighborhood, because the distance decay really discounted all the pedestrian volumes if the distance is far from the station areas. So if we think about the efficiency, of course, this concentrated kind of way of urban planning is more better. But maybe if other kind of urban planner thought that maybe more dispersed type is better, some regions for this neighborhood, this type of urban planning is will be selected. So actually, this accessibility analysis can use for this kind of actual urban planning or urban design project to evaluate how to evaluate people movement before the new design and after the new design. Yeah. Okay. So let's move to our site and with NNA toolbox. So first, I will just briefly summarize again. First, we have to do betweenness analysis, right? To compute this existing condition first, and then decide which location based on the result of the betweenness analysis. So you guys have to decide which location you want to count within this site. And here I can show you the counting sheet, like here. So you can print out this Excel sheet, and then you can go and count. It's pretty much, I can show, here is an example file as well. So once you decide the location, of your counting location, uh, you write down your name and write down the location and street name, or maybe if you are working as a team, you just your team just define the street number and then counting time. Like let's say afternoon peak hour, you guys go and just calculate it, and you just write down here and go there, and then start to simply count the pedestrian numbers there. But maybe I have to say X.
Next,
Oh,
there's a question from
oh yes.
Yeah.
What is the question?
Yeah.
I cannot see.
So I just wanted to know, so let's say we are performing the manual counting of pedestrian on Monday, 4 to 6. How to verify whether our data is right or it's an outlier? Like, let's say there is an happy hour on Monday, which could lead to increase of the pedestrian flow on Monday, but on Tuesday, for the same time, there would be less people. So how do you know whether it's represents scenario for most of the time versus it's an outlier?
Mm-hmm. Yeah, actually, in transportation planning field, we separately counted weekend and weekdays actually. So of course, if we look at very detailed kind of changes in a city, will be very different, like Monday, Tuesday, Wednesday. But in general, like what we are doing is that we just clearly define like weekdays and weekends, and we separately count as a different kind of condition. And as you can see here, this diagram, of course, like morning peak hour, even though it's the same location, but the morning peak hour and afternoon peak hour and evening peak hour, it shows a very different pattern, right? So actually this pattern can control by the decay value, because the road network is fixed, right? The origin and destination could be fixed, right? But like this kind of volume can be controlled by the decay value. So for example, the Cambridge case, we counted like evening peak hour, but it was a snowy and very cold day. So we used a 0.004 beta value. But if we count the location, same location, but maybe in the morning peak hour, and then the weather was super nice, and we will use the beta value with 0.001, something like that. Or you can also design the scenarios. Like I showed you the previous project show that we designed the 3 different scenarios, right? So first one, we just consider the residents in the area. But second scenario, just we consider the workers. And third scenarios, we consider both. And actually, this is a still very simplistic kind of way of scenarios, but you can kind of build your own scenarios in more kind of complicated way. Like, for example, if you count like CBD area, maybe you count office workers, but you count like retail locations as your origin. Instead of just people, you can also use building as your origin point. So you can actually design, and so your hypothesis is so important actually.
And
So,
also, in my opinion, so I think you are correct because it's really important and it's impossible to figure it out by just looking at some time, right? But at least we know, get some sense of the the pedestrian flow. I think this is also good way. Obviously, as time goes by, if in case we have a much more data, obviously we can make a more precise result. But I feel like we can consider this data, even if it has an outlier, so we can consider it's sort of a representative, let's say, time and section of the particular place data. Yeah. So I think this question is very validated, but we have some safeguard to understand. I mean, we are not believe the data as it is. So yeah, obviously, yeah. Thank you for bringing up the question, by the way.
and also like, yeah, also if you can find the outlier, that research project will be very successful as well. Yeah, because you design and your hypothesis and compute like using the network, and then you set the origins and everything, but how much differences or gap between your computing analysis and then actual counting, and if you find the kind of outliers, and then you know why these outliers happen in this area, maybe the your kind of input data was wrong, or maybe the data itself could be outlier kind of data, and or maybe you set up the different kind of hypothesis, or like you, yeah, there could be many different reasons. So that's why we designed this on-site survey program in this workshop, because you can get some sense. Like, of course, with computer we can do many things, right? We can evaluate that and this. It sounds kind of impossible everything, but like we are dealing with the actual site, right? So we just want you guys can experience on site, and then also feel about the kind of this data, you know, with your experience. That's our kind of goal. Maybe.
Yeah, we have a limited time, so you can go a little quicker, please.
Yeah. So yeah, so here the counting sheet, I can show you. Like, it's simple. Go and count the number of flows here. But yes, I have to say this. So actually, the 15-minute period is kind of reasonable. So of course, we can stand there, like you can count like 3 hours. It'll be perfect. But after all many researchers analysis and study about this, actually like 15-minute period is kind of like reasonable and kind of reliable as a data. So what you will do is that you visit one site, one location, and then count for 15 minutes. And after that, you expand this your counting number to 1 hour. So you counted 15 minutes, right? So it's a quarter. So you expand this value to 1 hour data. So it will be like 4 times of this value, right? So what we want to know is that you just record the result of between this index value. Maybe it could be like 0.034, something like that. You can just get the between this index from your NNA analysis, and then you just, here is your actual counted data, and here is expanding data for 1 hour. So this is the kind of final result what we want to expect. So yeah, and then yeah, I will show you the example file of NNA toolbox. So actually in the first lecture, we already show you how to do the betweenness analysis already. And here is the result. I just capture it. So can also just find here, but I will just quickly just explain. So also we added this example file on our server, right, NJ?
Yeah, you guys can download it from the plugin. So basically, the zip file not only contain the Agile file, but also contain all the examples that we show you guys.
But actually we cannot access to the Excel file for the count
Oh, really?
sheet, so I think you need to change the authorization.
Oh, okay. I will check it after the lecture. Thank you for letting me know. And so this is the betweenness analysis results. So I will distribute this data. But here, one thing is that actually what I'm doing here is that I just assume that or I use the origin with the entertainment and retail building, and then destination is the Hangang River Park. But actually you can design your hypothesis. So here is a data set for Seoul, so this area. But like here is metro data, and here is the bus data and retail entertainment data. But like this, actually the home data is a super huge. So if you have a really good computer, you try it out. I have my computer is not super good. It's just kind of working okay, but it's very slow. Like yeah, but like if you really want to test with kind of housing or like residence issue, just let me know how I will guide you how to use it.
Okay, so otherwise, we can actually, I mean, sorry for interrupting, but we can actually minimize the point if you guys has a particular research topic.
Yeah.
We can minimize we can actually have a ratio and then minimize it, and then we can multiply the result so that we can reduce the computational expense happening inside of the network. I mean, this is one of the strategy to dealing with the complexity.
Yeah, but at least I just want to share all the data. So, but if you really want to test with the home, just let us know first, okay? It's working slowly, but we just want to make more efficiency kind of work progress. And here you can see the all betweenness index results, like you can see 0.006. So for example, if you want to examine a place here, and you just check so you want to examine here this location. So what you should do is that you record like 0.091 like here you can write down here, and then you can decide like what is the street number and count there and then multiply it for. So that's the progress. And from here you can understand the result of the data. So the beam graph showing that what is the top 10% value and then what is the bottom 10% value. So you can control this domain, and then you can define the value range. So here you can see that this is the top 10% value is a 0.3 something, right? Almost close to this. So yeah, you can control this range, and then you just quickly get the sense which number is the top percent and which number is bottom top percent. So we're gonna share this file, so please check it out, and if you have any question, bring it to our workshop session. And then yeah, lastly, and you don't need to actually just do the betweenness analysis. You can also do other analysis as well, like other kind of centrality analysis or accessibility analysis, and then you can also decide which point you want to go and calculate the pedestrian flow. So just bring your hypothesis and idea, and then talk with us. And lastly, we just very quickly talk about the COVID-19 urbanism issues. It's kind of new normal these days, right? So it's many people concerned about it, and particularly in United States, we have a really kind of tough time. So in Cambridge, we have like new regulations are already applied in our life. So for example, this was a car road, but it just became a shared street. So car cannot access here actually. At certain time, only bicycle and pedestrians can use this street. And of course, the layout of the pedestrian street is different, like food pickup zone, and the layout of restaurant is changed, like outdoor dining and outdoor uh, table is kind of common in US, and also the direction of the walking is already kind of defined for public spaces actually. So we can just walk like one way kind of travel. We can make it. And as you can see here, this kind of blue dot line is the designated as a shared street now. So in US, like if you visit the Google map, you can see this kind of blue dot line. So this one means that it was a car traffic road, but now it's used for pedestrians and bicyclers. And you can see like here is the new regulations to make streets safer. And again, here is the kind of new layout for outdoor dining and restaurants. And if you really want to check the mobility data before COVID-19 and after the COVID-19, you can check here, the Apple Map. They provide the city data. It's so interesting. So how people move more during after COVID-19 or like move less COVID-19 and so on. You can check here. And also, not only just the travel data, it's also showing kind of the type of travel. Also, you can get the data from Google Maps. So you can find this link and then check this data, because these are kind of good to think about your research hypothesis. So yeah, visit the site and then think about your research. And here is another research from Manhattan. They began to measure the width of the street, and then they measure analysis about the quality of social distancing in this path. So of course, if the path is very narrow, it will be very difficult to keep the social distancing, right? So like Manhattan is very old city, and the path is very narrow, pedestrian path is very narrow. So they really want to bring up these kind of concerns and want to share with public and find the solutions with people. And here is the design guidelines for COVID-19. So this guideline coming from National Association of City Transportation Officials. So they focus on the public spaces rule. So they provided like 12 different situations, and this is like critical service. So they just transform street as a kind of these critical service places. And this is managing speed. So instead of just the straight street, they make a curve and then give a space for pedestrians, and then cars should reduce their speed, right? During this curve. And sidewalk extension, and this wide street, how they can design the corner of the street. And they just make it share the street, and they make an open play street. And they expand to the bicycles and bus stations and bus stops with other multi-transit nodes. Yeah, they just want to make like slow street. Pickup zone, this is very popular in US now, and outdoor dining, and became a market. And for protest, even for protest, and for school. and some like open door, like outdoor events. So yeah, please check this my Medium, and I kind of create a link here so you can download the whole the report of this guideline. It's so interesting. You can just read it. So I provided all the link for these files and data. So please visit it and then check it, use as your research ideas. So yeah, that's it. It's done for today's lecture, and let's have some kind of Q&A time.
Yeah,
And
so before we have a Q&A or discussion, I have one news for you guys. So we try to make a plan to have the Korean version of this lecture on this weekend. I mean, it's fully up to you. I mean, but the content is gonna be identical, exactly same. But we wanted to make a like Korean version of the lectures. So for those who couldn't, understand the English properly, so I think this is good for you guys. So, I mean, if you are interested in the Korean language, I'm happy to invite it to other people outside of Korea. So yeah, I mean, once we fix the time, then we gonna, release the sort of agenda or time to you guys. Yeah, but this is just information.
yeah, and probably the one of the Saturday or Sunday, like you need to a group should visit on-site survey. So we understand the weather in Seoul is not very nice these days. So we check the weather and let's talk about the schedule for on-site survey, and this also coordinate with our another Korean version lecture.
Actually, in Seoul, the monsoon has just left, so now it's like.
Oh, really?
But the extreme heat wave has come.
Okay.
So it may be like a bit tiring if they go out for a long time.
Yeah, it'll be like 15 minutes kind
And
of.
maybe there will be like no one in in the park.
Oh, I see, I see. No one in the park or no one on the street.
Yeah, because on top of that,
yeah.
recently, like since last weekend, there's another like COVID rush.
Oh, yeah, I heard
So
that.
like the newly infected get doubled every day at the moment.
We'll see. Yeah.
Yeah, let's see. Like, yeah.
So maybe the result is not
very
as good as expected.
I think the Saturday is, I don't know. Saturday is a raining day according to my weather forecast. So in Seoul. So Sunday is I don't know. It's gonna be changed by the way. But yeah, we'll let you guys know the time once we fixed. So again, for those who wanted to take the Korean version of this lecture series, yeah, please come and we can make a very concise same material.
혹시 영어로 힘드셨던 분들은 주말에 한국말로 다시 알려주신다고 하니까 시간은 이제 좀 조율해가면서 추후에 공지를 제 생각에 슬랙에 우리 다 같이 투표 같은 거 할 수 있으면 그거 해도 괜찮아요.
원래 생각했던 게 뭐냐면 일요일 날 비가 오면 토요일 날 하고 토요일 날 그 온사이트 일요일 날 하려고 했는데 일단은 그건 한번 우리가 이야기를 해보고 그다음 공지를 해서 다른 분들도 다 듣고 싶으면
그리고 혹시 모두 시간 맞추기 힘드신 분들은 그것도 녹화해서 링크 드릴 테니까 나중에라도 영상 보시고 참여하셔도 괜찮을 것 같아요.
오시면
더 안 되시면.
좋을 것 같긴 해요.
Yeah, let's do Q&A session. Yeah.
다 잠시 다 초대 드렸는데.
I have a question regarding the workshop session.
Sure.
I only listened to first week, and I was attempting to join yesterday's workshop session at 9, but I wasn't admitted to the Zoom.
Oh,
Is that workshop session only for the people who take those weeks?
I think I have no right to answer this question.
I don't know about
I have no
this.
idea.
Do you know about it?
I missed the question while reading the chat. Sorry.
Yesterday, I was trying to get into the workshop session Zoom because I got the link, but I wasn't admitted to the Zoom meeting.
Yesterday?
Yeah, I had
In the morning?
around 9:10, and I waited for another 5 minutes, 5-10 minutes, but I couldn't get into the meeting room.
Really?
Is
I
that
don't know.
can I join tomorrow? Basically, my question is, can I still join tomorrow's workshop session?
Yeah, sure.
No, Sunga, I think what she just said is that she couldn't get into the extra session for the unit 2, the morning session that you had, right?
Yeah.
I think that's because they've created a separate session for the for like extra description for the people who's joining the week 2. But there's no reason why you can't join. So I think if you still want to for the extra session, then I think you can. Oh, I think Sunga, you've got the. Who's actually inviting?
I sent it out
the
through
Slack?
an email to
Yeah,
everyone.
yeah. We can invite you again. Yeah.
All right, that'd be great. Thank you.
I think there was a problem with the setting of the room. Actually, the Zoom room that I made, like it was a default setting that I need to allow you to enter.
Yeah. So I
But-
basically I wasn't allowed. I wasn't allowed for a while, so I thought I was like I just can't get in. But anyway, that's great. So tomorrow I'll join.
All right.
Thank you.
Is there any person has trouble with Slack? 여기 슬랙에 공지 못 받았다고 한 사람이 있는 거.
But the rest of you, did you all get the link to the stack? I've seen some of us already joined and left some comments there.
No question? We finished.
은솔이
If you have a question, just leave it on chat and we can answer.
한국말로 주셔도 돼요. 질문 있으시면.
혹시 그럼 내일은 수업 전에 뭐 준비해야 되는 게 있는 건가요?
내일은 그 엑서사이즈 호목 있는 거 계속 하시면 되고요. 그리고 이거 오늘 그 설베이 하는 거 비트윈리스 한번 해보세요. 그 비트윈리스 어널리시스 해보시고, 근데 제가 다 만들어놔서 example 파일로 드리긴 했는데 그 비트윈리스 해보시고 뭐 클로즈리스 해보시고 막 이거저거 해보세요. 거기에 있는 거. 그 이것저것 해보면은 조금 감이 생기실 거예요. 아, 나는 이런 걸로 하이포테시스를 해서 가서 온카운트 한번 해보고 싶다 이런 게 느낌이 생길 거거든요. 그러면 이제 그걸로 그냥 내일 브리플리 얘기하면 돼요.
무엇보다 일단 어떤 걸 내가 연구를 하고 싶을지 계속 해오세요. 그러니까 그게 만약에 이거 할 거예요 라가 아니어도 아, 이런 생각 중에서 고민하고 있습니다. 이런 아이디어 하거든요.
그리고 그 파이튼 그 남주 선생님이 주신 거 이렇게 차례로 하고 계시면 그것도 이제 혹시 질문 있거나 잘 안 되는 거 있으면 내일 물어보면 될 것 같아요.
그리고 시간 뒤에는 또 그 제가 파이썬 튜토리얼 계속 해드릴게요. 내일.
네.
any questions related to next week's project, or any initial thoughts and ideas that you have, or the methodology?
여기 질문 하나 왔는데, 그 시나리오 3개 검증했는데 이제 사람들이 지금 가는지 이걸 어떻게 확인하느냐, 사실 이걸 확인할 수가 없죠, 그렇죠? 그렇기 때문에 이걸 시나리오 3개를 해서 비교를 해보는 거예요. 그러니까 이제 컴퓨팅은 사실 실제 가서는 이제 설베이를 해야겠죠. 가서 당신 회사에서 지금 오는 길입니까? 뭐 집에 갑니까? 이렇게 물어봐야 알 수 있는 거잖아요. 근데 그거는 우선 할 수는 없으니까 이제 거기 현장 가서 카운트를 해서 오고, 이제 저희가 컴퓨터로 어널리시스를 할 때는 시나리오를 나눠서 할 수 있잖아요. 그러니까 그러니까 뭐 레지던스 가는 사람, 뭐 오피스인 사람 이렇게 구분을 하잖아요. 그래서 이거의 코릴레이션을 보는 거예요. 두 개의 상관관계가 어느 게 더 높은지를 보는 거예요. 당연히 그 걸어가는 사람이 다 섞여 있겠죠. 뭐 일하는 사람도 있고, 뭐 집으로 가는 사람들도 있고, 아니면 그냥 슈퍼하는 사람도 있죠. 그렇기 때문에 사실 코릴레이션이 100%라는 건 나올 수가 없는 거고요, 사실은. 이게 항상 아웃라이어가 생기고, 이렇게, 100%는 될 수가 없는 거죠. 그래서 이제 이거를 확률적으로 보는 거고요. 이게 확률적으로 이런 사람들이 이 시간대에 많이 다닌다. 그러니까 이게 100%라는 건 없어요, 사실은. 이게. 근데 저희가 이제 계속 모델을 굉장히 소피스케일하게 현실에 가깝게 맞춰 나가는 거죠. 근데 제가 오늘 보여준 예제는 이렇게 사실 이게 막 세밀하게 가다 보면 뭐 비즈니스 어널리시스도 하고 막 진짜 다양한 걸 많이 해요. 근데 오늘 보여준 예시는 되게 베이직한 예시 보여주는 거예요. 되게 스트레이트포워드하게 이제 가서 온사이트 리서치 하는데 도움될 수 있게 보여줘요. 네, 현장 카운트는 우선은 현장 카운트는 다 같이 하시는 게 좋을 것 같아요. 다 같이 하지만 아마 다양한 하이포테시스를 가져더라도 결국 가서 카운트를 해야 되는 지점은 비슷하게 나올 거예요. 결국은. 그렇기 때문에 다 같이 나눠서, 이게 공원이기 때문에 제가 오늘 렉처한 것 중에서 랜드 유즈 타입에 따라 또 그 패턴이 바뀌잖아요. 그래서 제가 봤을 때 오후 피크 아워에 가는 게 좋을 것 같아요. 한 뭐 12시에서 3, 4시 사이 가서 카운트를 하는 게 좋을 것 같아요. 근데 그 사이에서는 언제든 가도 상관없어요. 그 오후 피크 아워 안에 걸리기만 하면 되고, 15분 가서 이제 카운트 하는데, 제가 봤을 때 한 20군데 정도 가서 하면 좋을 것 같은데, 그러니까 15분씩. 근데 지금 계시는 분들이 뭐 한 몇 분 정도 가실 수 있잖아요. 6분? 5분 가실 수 있다고 하면 이제 한 1시간 정도 시간을 보내고 오면 되는 거죠, 사실. 가서 내가 네 군데에 서서 있다 오면 네 군데에서 15분 서서 오면 되니까. 그렇게 하면 돼요. 네네, 오늘 보내드린 그 서울 거기 가시면 될 것 같아요. 거기가 어디냐면 합정역이랑 그쪽이거든요. Oh, sorry, we just speak in Korean. I'm very sorry. I feel bad. Sorry, the question
하나 더 있거든요. 이거 대답해 주세요.
is in Korean, so sorry about that.
There's a question from Nada. Could you check the chat window?
Yeah, is it? Sorry.
Did we start to work on scenarios before the survey?
Yes, sure. You have to do it. So you have to do many exercises with NNA toolbox, actually. And you will get the sense that, oh, this scenarios sounds good, or this scenarios sounds interesting. Nada, if you can find your city's data, you can bring it, and we can do as well. If you want, we can help you out how to build the data and like this. You can help out if you want, or you can still exercise with the whole data as well.
So if you guys have a question related to the inside survey, we have a Slack, right? So we can take advantage of the Slack.
Yeah. And we can also organize like who go there and who go there, and like it could be teamwork, you know, even though you have all different scenarios and hypotheses, but in the end, maybe you will get kind of like similar the results, I think, the decisions, I think, in terms of the counting locations. So please play with NNA tool today, and then get some sense about the site, and bring your hypothesis or scenario tomorrow workshop day. Oh, tomorrow, yeah, prep workshop.
Any more questions? Oh, actually, the link to the Slack was sent to the 1 week and 2 week program applied students to Unit 2 especially, but those who asked for the link or applied to Unit 4 actually on my attendance list, so I sent them another link to them.
And for NADA, like if you want to collect data from your city, of course we need the road data, right? So road data and the origin and destination point data. So if you have a like building footprint data, it will be okay because we can transform the data into the point. So
Probably
yeah.
local
It's kind of like general urban data if you can collect like
Yeah.
land use data or
Yeah, probably local government has some building footprint or network data.
yeah.
Otherwise, you can use OpenStreetMap. Yeah. So, but the line is could be dirty, but at least better than nothing, right? So.
And maybe in terms of the scale of the data, maybe we are look at kind of pedestrian kind of walkability. So maybe like the 1 kilometer radius could be okay. Yeah. Yeah, and if you have more questions about the data, and just leave some questions in our Slack, I will answer to you and help you out collect the data. I don't know like which city or location you wanna search.
So
You can keep talking on through Slack as well.
So I feel like there's no question related to the lectures. So I think yeah.
We can wrap up.
Oh.
Yeah.
And we'll meet tomorrow at prep session, right? So yeah, have fun and revise what we've learned today, and maybe we can bring out some more questions tomorrow and more discussions.
Sure. Yeah. Okay. Thank you, guys. Thank you for joining the lecture today. Thank you.
Great.
Yeah.
Thank you. Bye. Good night and good afternoon.
Yes.
Have a good time wherever you are.
2 a.m. I guess in Boston, right? 2 a.m. right?
Yeah, here's 2 a.m.
What
Yeah.
about Nada should be
Yeah, Nada, what time is it there?
It's 8:17. We did start at 4 a.m. here.
Oh my gosh. Wow.
Egypt, right? It's crazy.
Yeah, I mean, I get up pretty sleepy, but yeah, I have to get some caffeine in my system to be able to concentrate.
I appreciate you.
Yeah, I know.
Thanks
Yeah,
for the
Mayor, you are very late as well, right?
Yeah, it's Illinois. It's 1:20 a.m.
Yeah. Wow, it's very late. Okay.
LA is 11 p.m. It's okay.
Yeah, still okay. Okay, thank you guys.
Thank
And
you.
enjoy the lecture and workshop. Yeah.
Enjoy the NNA.
Good luck. Yes.
Thank you.
It was really,
Thank
really
you.
fun.
guys.
Bye.
Bye.
Bye.